All right, guys. The topic for today is quadratics. We are starting quadratics today. The first part of quadratics is really C-sec quadratics. We do a little extra on it. So we're doing that C-sec quadratics today. It is so much C-sec, I'm going to go straight into the examples. I'm going to do this topic by example today. So this is actually the 2022 AdMath paper. All right? This is the 2022 AdMath paper. What I'll do, I'll word the question, but then what I'll do, I'll add on to the question additional things that they might ask. There are some other things in quadratics that we have to know, which is new, that is not in C-sec. But we're doing those in the next class, like sum and product of roots of a quadratic equation, and the nature of the roots of a quadratic equation, and how we use the nature of the roots of a quadratic equation. But for today, we're focusing on the quadratic function, the shape of the quadratic function, whether it carries a maximum or a minimum, the inequality associated with quadratic function, finding the roots of a quadratic function, and finding range. That is something that we did not do in C-sec. Range of a quadratic function for a given domain. What I'll do, I'll implant those additional things on a question to cover the various things that they might ask you. All right? So I'll do what they'll ask you, what they ask you, and then I'll do additional things. Trust me, this is C-sec stuff. I don't have to teach this by going through notes. All the notes for the C-sec is in your handout. All the notes in the handout on the quadratics in the first part of it is the same thing that you'll find in the notes that I gave to the C-sec students. So we're not going to waste any time go through that. We're going to go straight to the question, do this part of it by example. We'll come to the other part of it, which is sum and product of roots, and the nature of the roots. We do the formal teaching of those parts of it. All right? So let's go. Everybody online go to that? Online, everybody go to that?
Yes, sir.
All right. All right, so this question gives us this function g of x. And the first thing it wants us to do is write it in this form. The question in C-sec would look exactly the same as that. They want us to complete the square. In C-sec, we would have used a method in our class to calculate xt and yt and all of that, right? We're not doing that now. We're advanced students now. So when we complete in the square in a similar way that we complete the square, we're doing the equation of a circle. All right? That's what we're going to do. We're using the process method now. All right, so let's go. So we want to get this in this form. We want to get this in this form. All right? Now, the first thing I want to do, you want to get it to, you want something like this to complete the square of or 4. Oh, sorry. Go on, just press it off for me. Yeah, sorry about that. Right, you want to get that to complete the square 4. Good. So the first thing you therefore want to do is factorize away the 6. We want to factorize it only out of these two terms. Leave the negative 80. Factorize it out of those two terms to generate your x squared plus nx. Because we looked at completing the square of expressions of this form. X squared plus nx, a 2-step process. All right? And so I'm going to factorize away the n squared first. So I'm going to get that this is equal to 6 curly bracket x squared plus 6x minus 18. 2x, my mistake, 2x. Thanks for that. I factorize with a 6, I'm getting 2x there. And I'm going to complete the square of inside here. It's an easy 2-step process. The 6 is a factor, or a factor. And then inside here, it becomes x and half of this coefficient, which is a positive 1 in the bracket. Square. Then you subtract the square of this, which is 1 squared. I'm putting on the square this time just for illustration. And then that is all inside the curly bracket, and you minus by the 18. Let's write down what we did. Let's just write down what we did. What I did was to take half of this coefficient here and subtract the square of this. That is always the process. After you get it in the form x squared plus nx. After you get it in the form x squared plus nx, then you do the half of the x coefficient and subtract the square. I explained it in the last class why this is so. If you don't know, remember, look back at the video of the last class. I explained it in the last class why this is a process. We are reversing the process of how we expand the perfect square. All right? Continue. We can now expand again away with this 6. So it becomes 6 times this thing, which is 6 into x plus 1 squared. 6 times negative 1 is negative 6. Negative 6 and negative 18 is how much? Negative 24. So 6 times this is going to be 1. So 6 times negative 1 is negative 6. Negative 6 and is negative 18, give me negative 24. And this is it. I have completed the square. Simple as that. So g of x is equal to this. All right? G of x is equal to that. Then it says, use the expression to determine the roots of g of x. Roots of g of x really are referring to the x values where the graph of the function would intersect the x-axis. That's what they're referring to as the roots. You get the roots by solving the equation. So the equation would be really solving g of x equals 0. But you get the roots from solving g of x equals 0. But the question is forcing us to use this to do it. That's why it says, use the expression derived in C1. So putting this equals 0 to get the roots. So we're going to put the 6 into x plus 1 squared minus 24. Put that equals 0 to find the roots. To find the roots when the quadratic is equal to 0. The quadratic expression is equal to 0. The roots are the points where the graph would intersect the x-axis. Those are called the roots. The y value is 0. The g of x represents the y value. And so you know solving this. Transpose the 24 and divide by the 6. You get x plus 1 squared equals 4. But can I say that equals 4? 24 divided by 6 is 4. That's all?
Yes, sir.
And there was square root both sides. Remember, when you square root, you have to remember it can be plus or minus. So it means that the x plus 1 is now equal to plus or minus 2. But the square root of 4 is 2, or is plus or minus. Everybody understand how I get that? Right? And then to find the x, we're going to transpose it to 1, and then x equals negative 1 plus or minus 2. The two values of the roots, would be x equal minus 1 plus 2. That's a 1. And the other root would be x equal negative 3. Those are the two roots. X equals 1, x equals negative 3 are the two roots. All right, now I think this question done. Or they say sketch it. They want us to do a sketch of it. I'm gonna sketch it I'm not gonna sketch it on the graph. They want us to do a sketch of it. All right? All right. All right. So watch me now. I'm gonna do a sketch of it over here. I'm doing it over here because I want to emphasize certain things. All right. Now, firstly, this form of the quadratic, we'll put it in the vertex form. It is really meant to show us where the turning point is. That's what we call it, the vertex form. It shows us where the vertex is. That's why we complete the square. The quadratic equation or the quadratic function can be written in 3 different ways. Can be written like this, the standard form, like y equals ax squared plus bx plus c. That's the standard form. Can also be written in the vertex form, which is y equals a into x plus h squared plus k. And can be also written in the factor form. Y equals a into x minus 1 root times x minus the other root. Can be written like that as well. All right? How these work? This first form gives you some information about the quadratic function. Depending on the A, you know whether the function has a smile shape or a frown shape. If the A is positive, it will have a smile shape. And if the A is negative, it's going to have a frown shape. Hold on a second, guys. I need to turn on the AC. Don't pause the video a bit. Hold on. Forgot to... Right. So as I was saying, this is a standard form. It tells you some stuff about the quadratic function. So the A tells you the shape. The A positive, you know that the quadratic function will have a smile shape. If the A negative, it's going to have a frown shape. That's what the standard form tells you. The C out here is a y-axis intercept. That's the point where the graph crosses the y-axis, the C value. So the standard form tells you give you 2 pieces of information. The shape based on the A and the y-axis intercept based on the C. Let's say I have a smile shape. Standard form tells you the shape and also tells you the C. So let me put in a y-axis now. Put in a y-axis and put in an x-axis here. So I'm going to put that standard form up here also tells you the C. This form, which is the vertex form, it's called a vertex form because it tells you where the vertex is. Let me change the color of it. That vertex form tells you where this point is. That's what the second in red tells us. Tells us where the turning point is. The vertex form. Right? It also tells you what the maximum value is. In this case, the minimum if it is positive. This becomes your minimum value or maximum value. And you get to that maximum or minimum value when the expression in the bracket is equal to 0. I want to explain the maximum and the minimum one time. Just to say that we're not just accepting that's a maximum minimum. We understand why it's a maximum minimum. I'm going to explain it one time. And then this other form now, which we call the factor form. Let's change the color of that one as well. It's in purple. It didn't change. Tells us where the roots are. Well, this one, we never put no roots on it. So let's draw the y-axis here so instead. Let's try this instead. It tells us where the roots are. So the form that is in purple will basically help you to know that one root is here, R1, the other root is here, R2. And that's why you have the need to do 3 different things with the quadratic function. Standard form gives you some information about it. The vertex form, the second one, gives you information about the vertex right here, and whether you have a maximum or minimum value, and what value of x gives you that maximum or minimum. And then this form tells you the roots. So every time they ask you to complete the square over here, you can pull information about the vertex from that form. So let's talk about why it is maximum when the A is negative and why it is minimum when the A is positive. Let's talk about that a little bit. All right, just in case we didn't know before. I'm using examples to teach the topic. All right, to teach the topic. Let me show you now. So let's say, in the case of this one that we have, let's explain it. It is g of x equals 6 into x plus 1 squared minus 24. We know from CSEC that because the A positive, this is a minimum. The minimum value of that, we used to say is YT. Why about the turning point? Why is it minimum? All right, think about this now. This squared term here can only be greater than or equal to 0. Get me? The square term here can only be greater than or equal to 0. Can't be less than 0. The lowest value that this square term can be is 0. So it is as if this function starts at negative 24, and then you can only add to it. You can only add to it because the square term can only be 0 or more. So if you start at negative 24, it's a constant, and then you can only add to the negative 24. It means that the negative 24 is the minimum value. Understand that? And that's because the A positive. Now, what if the A was negative? Let's look at if the A was negative. Let's say the function was such that the 6 was negative. Let's write that now. G of x equals minus that now. Again, the term that is squared right here can only be greater than or equal to 0. That term can only be greater than or equal to 0. But you are multiplying that value with a negative 6. Right? So because you're multiplying by a negative 6, then it means that overall now, all of this can only be less than or equal to 0. But the negative multiplier turns it into a negative. And then now, if you're starting again at negative 24, and you can only subtract from the negative 24, then the negative 24 would be your maximum. But you can only subtract from it. Understand that? So that is why if the A is positive, the constant is your minimum. But if the A is negative, the constant is your maximum. Right? Simple. But the A positive, you can add to that constant. If the A negative, you can subtract from that constant. All right. So basically that explains the maximum minimum. And then now, remember now, another thing now, which I ask you sometimes. This is your minimum. The function is equal to this. G of x is equal to this when this part is equal to 0. Good? The function is equal to negative 24, which is the minimum value, when the term in the bracket is equal to 0, when the x plus 1 is equal to 0. That is when the x equal negative 1. So the function can be equal to this value out here when the bracketed term is equal to 0. So the value out here is your minimum value, which occurs when the term in the bracket is equal to 0. This is all ad maximum coming from CSEC. Same thing they're asking CSEC. All right? All right. And in the other case, it's a maximum. When the A negative, it's a maximum when the bracketed term again is equal to 0. When the bracketed term, the term in the bracket, when the term in the bracket is equal to 0, the constant out here is your maximum value. And I just explain why it is a maximum, because you're subtracting from it when the A negative. When the A positive, you're adding to it. Therefore, it's a minimum, but you can add to it. So it's a minimum. All right. So this question is asking us to sketch the graph. It's asking us to sketch a graph. So we look at the 3 forms of this function right now to make a sketch and determine how the sketch would appear. The first form, which is a g of x equals 6x squared plus 12x minus 18. This given standard form. Since the a equals 6, we know it has a smile shape. That's a smile shape. But we're going to have to sketch it. We must know it has a smile shape for the a positive. When A positive has a smile shape because it has a minimum point, a minimum value. We also know the C value is negative 18. So when it comes to y-axis is 0C, which is 0, negative 18. So when we cut the y-axis at negative 18. So that's 2 things we get from the standard form. From the vertex form, we'll complete the square right here, which is the g of x equals 6 into x plus 1 squared minus 24. We know that the minimum value is the negative 24, the minimum y value on the graph. When is it minimum? When the bracketed term is equal to 0, when the x plus 1 is equal to 0, which is when x equals negative 1. This minimum value is a y value, so let me write it. Minimum value is y equals negative 24. Therefore, the minimum point has this x value and this y value, negative 1, negative 24. That's where the minimum point is. Negative 1, negative 24. I'm building up the information to make a sketch. So you know the shape, you know the y-axis intercept from the first standard form. Then you know the turning point. You know the turning point from the vertex form. Then now we actually calculated the roots already down here. We're going to intersect the x-axis. We have calculated the roots, right? And so the roots are 1, 0 on the x-axis and negative 3, 0 on the x-axis. Those are the roots. I'm going to put all that information together and make a sketch. All right, let's make a sketch with all that information. All right. So let's say that this is my sketch. What's the turning point again? Negative 1, negative 24. All right. Y-axis, x-axis. I don't care about the coordinates just now. We know that the graph has a smile shape. Just a matter of where does it turn. That's a smile shape, but where are we putting the turning point? We have to put the turning point here. Negative 1, negative 24. Negative 1, negative 24 is somewhere over here. So the graph must turn somewhere down here. So. Next thing is that it crosses the y-axis at negative 18, 0, negative 18. Negative 18 has to be somewhere down here. So it crosses the y-axis somewhere down here. And then it has two roots, 1 and negative 3. So one root is over here and the other root is over there. So your sketch is supposed to cover all those. See it here? Put it all together. Turn down here, cross somewhere down here, cross there, and cross over there. So. And it has a smile shape. So my sketch, therefore, is like this. And you label it. This has to be negative 3. This has to be 1. This has to be negative 18. This point has to be negative 1, negative 24. Negative 1, negative 24. Has to be my minimum point. That's a sketch of it. All right? We're going to add a couple more questions to this now. And use this as a tool. Will help us understand what I'm going to ask you next. Which is now the inequality. Inequality. All right? Now that we know the sketch, I can ask you a question like, let me make this a little bit smaller. I can ask you a question like this. Solve 6x squared plus 12x minus 18 equals 0. What am I asking for if I ask for that? I'm asking you for the roots themselves. The roots. So this is giving you the roots. This tells you the roots. And there are x equals minus 3, x equals 1. The roots are the points of the graph intersect x-axis. That's one thing I can ask you, relating to the roots. Another thing I can ask you is to solve 6x squared plus 12x minus 18 greater than 0. What am I asking you for there now? Remember, say you never learn this at C-second. Oh. Good. What? That's not it. Come again. What is this asking for? Solve this. I said if the question says solve this and ask you, what it asks you for? It's asking you for the roots. It's asking you for the roots themselves. X equal minus 3 is one root. X equals 1 is another root. Then I say, okay, the same quadratic expression or the same quadratic function, and I'm saying now greater than 0. What is this one asking you for? All right, let me put the question another way. When the question asks this, it's asking you, what are the values of x where the function is equal to 0? In other words, where my y values are equal to 0. Where on the graph are my y values equal to 0? That's what this is asking, you know. This represents my y values, you know. The whole function. Your function is your y value. Your function is your y value. Good. If this one is asking you, what x value will make my y value equal 0? Then this one is asking you, what x values will make my y value greater than 0? That's what this one is asking you. What are the x values that will make my y value greater than 0? My y value is greater than 0. Look at the graph and tell me. So remember now, see it here? On the x-axis, let me erase this and draw it over. On the x-axis itself, y values are equal to 0. Where on the graph are y values greater than 0? Where? Where on the graph are y values greater than 0? Above the x-axis. So above the x-axis, my y values become greater than 0. Up here. Any part of the graph that is up here, my y values are greater than 0. And I can go on and ask you, let me put it down here for part C. I'm going to write the answer soon. If I say solve 6x squared plus 12x minus is 18, not 8. And I say less than 0. What is this inequality asking me? What is this inequality asking me for? It's asking me for the x values that would make y less than. You start with this, as a reference, It's a similar thing, This equation is asking you to state the x values for which the y values are equal to 0. And those x values are these, because they are the points of the graph intersect the x-axis. Because on the x-axis, the y values are equal to 0. Then this one now is basically saying, what are the values of x that will make my y values greater than 0? In other words, what are the values of x that will give me the part of the graph that is above the x-axis? Because above the x-axis, my y values are greater than 0. And then if I write it this way, then this is saying the reverse. It says, what are the values of x that will cause my y values to be less than 0? Y values are less than 0 below the x-axis. Below the x-axis. Down here, y values are less than 0. So see the graph here, have the graph I look upon. See it there, so you know say your y value is equal to 0 when x equal 1 and when x equal negative 3. So look at it now and tell me what x values will cause my y values to be greater than 0. Look at the graph and tell. This one. So the x values So for up here, greater than 0, I would want the x values that are outside the roots. This way. To the right of this root and to the left of this root. In other words, a x value out here, like for example 2, is going to give me a y value up here. That is positive. See that? And an x value down here, which is less than negative 3, is going to give me a y value up here. So this other inequality is asking me for the x values that are this way and this way. So let me write it. This inequality, based on that sketch, my solution is going to be outside the two roots. Outside. I use the term outside. Outside the two roots, as compared to between the two roots. So this is my solution for this. So I say this solution are the roots themselves. But this solution now is going to be outside the two roots. Outside the two roots. Outside. Outside the roots. So I can tell you from now. The solution for a quadratic inequality is either between the two roots or outside the two roots. The solution for a quadratic equation are the roots themselves. The solution for a quadratic inequality is either outside the two roots or between the two roots. The solution for a quadratic equation are the roots themselves. So it's 3 things you can possibly get. Roots themselves, if you solve the equation where the quadratic is equal to 0, then you have the possibility of getting outside the two roots or between the two roots. And that depends on whether you have a smile function or a frown function. So I want to use a sketch method to answer this all the time. A sketch method. So for this smile sketch, outside the two roots, for where the graph is greater than 0, you can see the graph goes above the x-axis to the right of this root and to the left of this root, outside them. And when it's outside the two roots, the solution is that x is less than the smaller one, which is negative 3, or x is greater than the larger one, which is positive 1. And you have to write them as 2 separate inequalities. Why do you have to write them as 2 separate inequalities? Look at the graph. We have to say or. We have to use the word or. Why do we have to write them as 2 separate inequalities and use the word or? Because you cannot be greater than 1 and less than negative 3 at the same time. So it's an or situation. Either you're less than negative 3 or the x value is greater than 1 for the y value to be positive above the x-axis. Then this one now, this last one now, is referring to the part of the graph that is below the x-axis. The part of the graph that is below the x-axis is here, this turn part of the graph under here. So it is a value of x. Use a different color, green. It is a value of x, purple. It's a value of x anywhere in between here. That's going to give me a y value on the graph that is negative. It's a value of x anywhere in between these two roots. It's going to give me a y value that is negative. So the solution for this one is between the two roots, because this inequality is referring to this part of the graph under here where my y value is negative. And it is x values that are in between these two roots. In between these two roots that give me these negative y values. So the solution for this one is between the roots. Now, pure math students, we are going to have to do cubic inequality. You know? When we do cubic inequality, what you'll find is that you'll end up having situations where one part of your answer is between two roots and outside another root. That's what will happen. Your solution in cubic is going to be Like your solving, you're going to get between 2 roots, but outside a third root. But a cubic equation will have 3 roots. All right? So this is setting us up for the next topic, which is cubic functions. So pure math students have to understand this. We're going to extend what we are doing here to the cubic functions. So make sure you understand this. All right? So the solution for between the 2 roots is written like this. X is between, mean less than the larger root, but greater than the smaller one. That's all right between the 2 roots. One inequality between the 2 roots. That will be the solution for that one. All right? That will be the solution for that one. People online, okay?
Yes, sir.
All right? So I've introduced the inequality there. Let me introduce now the range of the function, which is something else I can ask you about a quadratic function, the range. Let's talk about the range of the function. All right, so we're working with this same function here that we have. What I'm gonna do, I'm gonna adjust the domain. Let me say I'm talking about the range of the function now. So we're going into range. So we just did the roots, we did inequality, we did the sketch, we did the vertex, we did the y-axis intercept, we did the shape. All right? When I talk about now the range of the function, the range will depend on the domain. Range will depend on the domain. And pure math students in particular will learn that even a quadratic function can change. For example, change to a one-to-one function by adjusting the domain. When you change the domain, you change the function. By changing the domain, you change the function. Pure math students in particular will have to learn to deal with that. But not yet. We're going to come to that. All right. So let's say we have the same function. G of x equals 6x squared plus 12x minus plus 12x minus 18. And we're going to say our domain is that x is real. That is all. X is real. And the question says, state the range. And the range is based on your domain. The range must be in reference to your domain. So given that this is a domain, state the range of g of x. So the domain, for want of a better word, is the spread of your x values. And the range, for want of a better word, is the spread of your y values. Just for want of a better word. So the domain are the x values that you can use on the function. And the range are the y values that you get for that given domain. So I show you this graph and I say that this is my domain. So when this is the domain, it means it's accepting all values of x from negative infinity to positive infinity. So if I'm sketching my function on this domain, what I would do is the same function up here now. I would put an arrow on the top of this one and put an arrow on top of that one to show that it goes all the way and all the way. There are no restrictions on it. Look at it though. What is the range of that function? Range is the spread of your y values. Look at it. What is the range of this function for a domain that has no restriction on the x? Look at it. What is the range? Huh? There's no restriction on the domain. Full, you can take any x value. So the full graph. That's why I put the arrow up here. An arrow up here. So it goes up to infinity and goes up to infinity. What is the range of that function? Range is the spread of your y values. The y values start from where and go to where. Start from the minimum. Remember, this is the lowest y value. So your range is from here upwards to infinity. From your minimum y value upwards. And remember, your y value is g of x. So your range then is that g of x is greater than or equal to negative 24. And your lowest y value is negative 24. And this function will basically have y values that are greater than or equal to negative 24. That's it. That's the range of the function right there. That's the answer. The range of the function. If the domain is x, is real. Well, let me go and change the domain now. Same function, but I'm adjusting the domain. I want you to tell me the range now. All right. Watch this now. I'm going to change the range. It's okay. Range, the domain I mean. So same function, g of x equals 6x squared plus 12x minus 8 on, the domain now is that x is greater than or equal to negative 3, less than or equal to, say, 4. What is my range? What is the range? Range again is the spread of your y values on the function. This is my domain now. So since that is my domain, let me sketch a graph. Know that this is my domain. It starts at negative 3 and goes up to 4. Stop right there, so negative 3 to 4. So I take that same sketch here, so I just copy it down. Since I have it already, so I'm gonna have a draw it over from scratch. I'm gonna take off what I don't want off. I'm taking the same sketch and I paste it down here, so now. Let me take this off. All right, watch this now. Because of that restriction, starts at negative 3. So it starts right here, don't it? Don't it? So use a different color and draw it. Draw it over this one. So it starts here, continues down, same way. Go through the turning point, come up here, same way. It's a 1 in. 1 up so. And it goes up to a point where my x value is 4. Let's say the x value is 4 right here. So not to scale. Goes up to 4 point and it stops there. So I'm putting a dot to show that it stops there. I'm going to take out the red one now. That is my function. CMG of x. But because I restricted the domain, it starts at negative 3 and it ends at the x value is 4. Question is, what is the y value there? So? What is the y value here? So when x value is 4, how can I find that out? Plug the 4 into the function, right? I work it out for me. So right here, so my y value, I can say g of 4 equals 6 times 4 squared plus 12 times 4 minus 18. Work that out for me. Work that out for me. 126. Don't worry about it. 126. Not to scale. Don't worry about it. 126. So we said this point is 126. That point is 126. So tell me now, what is my range? What is the range of my function? What is the range of this function now on this domain? The same function formula, but my domain has changed the function. range is gonna change. Stuff will change on it when I change the domain. The domain dictates the function. So tell me now, see there, what is my range now? Beautiful. It's from this up to this. Put them black. Beautiful. My range is now from this lowest value to this highest value. That's the spread of my y values on this function. From negative 24 up to 126. That is my range. So it's g of x. Write it down here, sir. My range. This is my range. This is my range. Highest value corresponds to that point. Lowest value corresponds to that point. Good? And this function for this domain. So I can write my range now as g of x less than or equal to 126, greater than or equal to the minimum value still of negative 24. So my range change because I change my domain. But I go to that. We'll tackle another question now, and ask some additional things now, with another question. But we use the question to solidify this thing that we're doing. We're going to ask the inequality questions. We're going to ask the range questions. We're going to change the domain and make sure we do this thing a number of times. Huh? To learn the various things we need to learn about Quadratics by adding additional questions to it. So far, so good, guys. So far, so good online.
Yes, sir, but if we could do more of the ranges and function range and stuff, because we didn't do that in advanced.
Not hearing so clearly. Go again?
Yes, sir, but like the range parts are confusing because we didn't do it in advanced. So
Something is confusing because what?
the range parts because we didn't do that topic in advanced.
You didn't do it in advanced. Well, luckily it didn't come on the exam. Because it can come, it could have come on the exam. Because range is a part of it. Why they didn't do it? This is one thing that they maybe would not have asked in CSEC, but it's a part of the ADMAT syllabus to find the range of the function for a given domain. So now you know it is done. Right? And you have to have this knowledge because they can extend this to a cubic function. And you have to know cubic function. Cubic function is really an extension of the quadratic function. Let me just give you a quick example of a cubic function. So the cubic function, you might have a cubic function, for example, going like this. Might have a cubic function going like that. And let's say these are the rules. I'm just putting in some rules. Let's say this is -2. Let's say this is 1. And let's say this is 3 or 4. And this is a function f of x. This is the y-axis. And this is the x-axis. For this, they could ask a question like, solve f of x greater than 0. I'm going to change and put a little sugar on it just now. But can I answer that? F of x greater than 0. What will be the answer for that? If this is the graph of fx, what will be the answer for f of x greater than 0? What will be the answer? Firstly, which part of the graph would this inequality be talking about? We're talking about the part of the graph that is above the x-axis. So to be talking about this part of here, so, and this part out here, so. See that? So the answer would be between these two roots, but outside this one. That would be the answer. So you write the answer like this. You write the answer like this. You would say x is less than 1, greater than -2, union x is greater than 4. That would be the answer. That would be the answer for that one. That's for pure maths. So part of it is between two roots, the other part is outside another root. That will be the answer for this inequality and that cubic function. Let me give you another one. Watch this one now. Watch this one now. Look at this one now. Pure maths. Hard maths won't get this. Watch this one now. Watch this one now. This point is on the x-axis, right? I'm going to put my y-axis right here. And let's say this function is g of x. Let's say this point is, let's say right here is -4. Let's say right here, so it's 2. You have a turning point right there at 2. Now I want solution for g of x less than or equal to 0. That's what I want. G of x less than or equal to 0. What part of the graph is this inequality referring to? Where is that inequality referring to? Somebody online tell me. What part, where on the graph is this inequality referring to? G of x less than or equal to 0. Where is it referring to? Nobody on the line telling me. Somebody in class tell me. Huh? Can't be just the roots. See the inequality sign there? The root is when it asks you equal 0. Equal 0 is when it asks you for the roots, because equal 0 means on the x-axis. Once it's an inequality, a part of the answer is going to have to be outside roots, between roots. The equal part of it is for the roots, but the less than part of it must be outside some root or between some root. So what will be the solution for this? All right, first thing we have to know, is where on the graph is this inequality asking you about? That's the first thing. Where on the graph is that inequality asking about? Less than or equal to 0. Now stop talking. Less than or equal to 0. Where on the graph is this inequality talking about? Think of the less than part and think of the equal. There are two things happening in there. There's an equal in there and there's a less than in there. So you're not asking for equal alone, you're not asking for less than alone. You're asking for less than or equal. Means you have to include the less than, you have to include the equal. So tell me where, so which part on the graph is this inequality asking you about? That's the first thing we need to know so we can answer it. It's asking us for the on the x-axis and also below the x-axis. All right. Tell me where on the graph now it's talk about. Now that you answer that. You say what? You say what just saw? That's it? Huh? And the 2. Because the 2 is for the equal to 0. The 2 is for the g of x equals 0. The 2 is for g of x equals 0. So you cannot ignore it. The 2 is where g of x is equal to 0. G of x is equal to 0 at the 2. G of x is equal to 0 at the 4. That's on the x-axis. G of x is equal to 0 at the 4, right there, so. And then g of x is less than 0 down here, so. G of x is less than 0 down here. So those are the 3 things this inequality I talk about, you know. I talk about the 2 for the equal 0. It talk about the 4 for the negative 4 for the equal 0. And then it's talking about outside negative 4. So the answer for this is this. Now, what is now? The answer for this would be what? You have to refer to the over that part here. So you just say, all right, the solution for this is that your x would be less than or equal to negative 4, don't it? Got it? So we have the equal 4 in it for the 4, and we have the less than negative 4 for over here. So see that? Union x equals 2. That will be the solution for this. Union x equals 2. So these are the 2 combination solution for that inequality based on this graph. Equal 2 because g of x is equal to 0 when x equal 2 because that point is on the x-axis. It also equal to negative 4. X is equal to negative 4 on the x-axis. And then for the less than 0 now, it is when x values are less than negative 4. Less than negative 4. So this will be the solution. Pure math students can write this. All right. We could jump to another quadratics question on another paper. All right. Let's jump to another quadratics question. People online okay with this? People online okay with that?
Yes, sir.
All right. Let us jump to another paper. Let's hope we can get a front one. Let's see. 2021. All right. So got this question now. Got this question. This is almost like a C-second. They give you that function. They say you must complete the square right here. Then down here they ask you for state the minimum value. C-sec. That's it. That's a K value. Then down here say determine the value of x for which it is minimum. So it's like a straight C-sec. How much marks I give for that? 5 marks for that, you know. 5 marks. To do that C-sec stuff here. That's it, you know. You know people feel that maths, you know. Don't know people feel that maths. That is C-sec. We're gonna do this question. I wanna add some stuff to it, right? We're gonna sketch it. In fact, I don't want. I want to do a front one. We can find a front one. We can see if we find a front one. I want to do a front one next. That's not a smile. Let's do a front one. And make the adjustment. Let's do a front one. All right, so a front one here, 2819. All right, let's do that one instead. All right. All right, so this one again wants us to complete the square, put it in that form. It asks us for the maximum. And it asks us to state the value of x, which is the maximum. And then it asks us for this, equals 0. But they want us to get it from the vertex form. They don't want us to use quadratic form. They want us to get it from that form, from this. They want us to use this to solve this equation down here. All right, then we're gonna add some stuff to it. See it? Them say sketch a function and show the solution set for this. So you see, you can answer that. But I'm gonna adjust it and I'm gonna do a little range part to it and so on, right? All right, let's do this one. So at least this one give us some inequality on it as well. All right, good. Much marks for this now? 2, 5, 6, 7, 10 marks for this now. 10 marks. Jesus, boy. 10 marks for the little C6 up here. 10 marks. 10 marks for the little C6. Yeah, let me zoom it up for those of you here. All right, so I want to complete the square of this thing. So remember, guys, when you want to complete the square, you're trying to generate, you're trying to get your x squared plus nx in the bracket, right? All right, you're trying to get your x squared plus nx in the bracket. Remember. All right, ready? Ready? Look here, now don't joke at the class, I'm running out tonight. Stop joking at the thing. All right, so we're going to factorize these two things. And people make mistakes all the time when the factors that are negative. You have to be careful. A common mistake, right? All right, so this is going to become negative 2 into x squared plus 7 over 2x. And you have about minus 6 out there. How do you go to that? I spend my right so beautiful at all. Good. They will complete the square of the terms inside here. Same thing as usual. Minus 2 into x and half of this becomes 7 over 4 squared minus the square of this 49 over 16. All of that in the curly bracket, subtract 6. What did I do? Let me write what we did again. I took half of this inside here and I subtract the square of that there. That's how we complete the square, guys, after factorizing. 2 steps. We're going to expand back with the negative 2, and again, be careful with the negative. So when we expand back with the negative, we're going to get negative 2 into x plus 7 over 4 squared plus 49 over 8. Look at the plus, minus times minus, give you a plus. And then the 2 cancels into 16, give me the 8. And then this 6 is the same as 48 over 8. So I'm going to write minus 48, not over 8, over 6. 6 is 48. So I'm going to multiply this by another one. Over 8 more, right? Over 8, sorry, my bad. 48 over 8 is correct. 48 over 8. Why did I do that? Because this is our denominator of 8. I want to convert this into a fraction with a denominator of 8. So I'm going to multiply by 8 and divide it back by 8. That's how I'm going to get this. But I want it to become a fraction with 8 on the denominator. And so this then becomes equal to minus 2 into x plus 7 over 4 squared plus 1 over 8. The next part asks me for my maximum value. See, state, no calculation, it is this. That's the maximum value. Calculation needed. The function is maximum when this inside here, so is 0. All right? Remember, I know that the function starts out with a value and it is always subtracting something. That's why that is negative. You start out with 1 over 8 and you keep subtracting values because the square term here can only be positive. Because you multiply with this negative number, you can only subtract from the 1 over 8. So the 1 over 8 is the maximum. You can only subtract from it. The 1 over 8 is the maximum that the function can do. 1 over 8. So the maximum value is y equals 1 over 8. Or f of x equals 1 over 8. F of x, f of x max is 1 over 8. And it says state the value of x for which it is maximum. That is when it is maximum when the bracketed term, when the x plus 7 over 4 is 0, which is when x equals negative 7 over 4. That's the value of x where it is the maximum. So the maximum point has these values. Those are the coordinates of the maximum point. This is the x value at the maximum point. That is the y value at the maximum point. Those are the coordinates of the maximum point. So I can write it here. Maximum point is negative 7 over 4, 1 over 8. This is my maximum point. This thing is my maximum point. Let's change it to red. That's my maximum point on the graph. And when you tell a maximum point, it frowns. All right, so somebody might ask, in terms of the graph, why refer to it as a maximum? Or why refer to it as a minimum? Let me just put a little perspective to it. Why is the minimum value and all of that in relation to the graph? So when we have a smile graph, like this, and these are your y values. So you have your y-axis, and you have your x-axis. You should always take the sense of a graph as if you're going from left to right. So if you think as if you're going from left to right, and you're tracking what is happening to your y values, because if you're going from left to right, it means that your x value is always increasing, you know. Going from left to right, it means that you're increasing x value, you know. And you want to see what is happening to your y value as your x values increase. So you go from left to right along the graph. If you're going from left to right along the graph, your y values are initially coming down. And they come down to this minimum, this lowest y value. Then your y values start to increase again. That is why this is your minimum y value. Over here, your y values are decreasing. Pure math students will get familiar with those terminologies. The function is decreasing over here. But the y values are going down. The graph has a negative gradient. Oh, boss, you come for talk. Over here, your y values are increasing. And they say it is an increasing function. Pure math students get familiar with those terminologies. When the function is an increasing function, the gradient is positive. Say you're sloping up, gradient is positive. What is this point called? It's neither decreasing nor increasing. Stationary. So a function can be doing one of three things. It can be increasing, it can be decreasing, or it can be stationary. When it is increasing, the gradient is positive. When it is decreasing, the gradient is negative. When it is stationary, the gradient is 0. Right here, it is stationary, called a stationary point. And down here, you know, the gradient like going straight across. Not going up or down, going straight across. Gradient is 0. So decreasing, stationary, increase. All right? So it is decreasing, so the function decreases to a minimum and then starts to increase again. That's why that's a minimum. And the reverse is true for a front graph. It's increasing first, increases to a maximum point, and then it starts decreasing again, starts coming back down. That's why that's a maximum point. The y value is increased to that maximum value at that maximum point. All these terms relate to each other. And there are questions where we have to use those terminologies, especially in pure maths. Increasing function, decreasing function. Function is stationary. Get me? All right. So let's do some other stuff with this team. We'll answer the questions them first, and then we can do a couple of other stuff with it. So far, so good, everybody. So far, so good with this, right? They will come to this now. They want us to find the root. Remember, once you solve f of x equals 0, you are finding the root. So the graph intersect x-axis. The question is forcing us to use this to do it. They don't want to use a quadratic formula. They don't want to try to factorize or anything like that. They are forcing us guys to use the answer in A1, which is that. So we're going to put that equals 0. So to solve this, we're going to put the function after we complete the square equals 0, which is this. You can just literally just copy it now. And put it equals 0 down here. And so I'm solving that for x. When I solve that for x, I'm going to get the x value that I'm getting at the roots. So I'm going to transpose this guy over here, so, and then divide by the 2. I'm going to get x plus 7 over 4 squared equals 1 over 16. Everybody can say that? A positive 1 over 16 too, don't it? Everybody can say that? And then we're going to square root. So I get x plus 7 over 4 equals plus or minus 1 over 4. But I can say that. Let me square both sides. But I say that. And then we're transposing the 7 over 4.
Yes,
I get, huh? But I good? Online?
Yes.
But okay online? Somebody was saying something.
Yes, sir.
Okay.
Oh, okay. We're going to get x equal negative 7 over 4 plus or minus 1 over 4. So from this, we're going to get our 2x values. One with the plus, negative 7 plus 1 is negative 6 over 4. X equal negative 6 over 4, which reduces to negative 3 over 2. And the other one, the other root is x equal minus 7 and minus 1. That's negative 8 over 4. Negative 8 over 4, which is negative 2. So based on these values, these are exact values, it means that this could have been solved. This could have been solved by factorizing, We don't want to do that. We're forcing us to use this form to do it. That's what it says. Use your answer in A1 to do it. But that is it. And where a lot of people make the mistake is right here, plus or minus. Forget the plus or the minus. But at this level, we must know that. When you calculate square root, it can be plus or minus. So these are our two roots, guys. Two negative roots, it has. Two negative roots. Both roots are negative. All right? Two roots negative. Remember the graph has a frown shape. And the y-axis intercept is this constant value out here, negative 6. And this graph is entirely below. What is the turning point again? No, that it comes above the x-axis. Right, it must come above the x-axis. That's why it has two roots, two negative roots. All right, we're gonna sketch it. It says sketch a function and solve this, right? So let's sketch it. Let's sketch it. Let's sketch it. I'm gonna put in my y-axis and my x-axis. I draw it like that because I'm visualizing function already. Right? Because it had a small maximum value, didn't it? 1 over 8, don't it? Small maximum value, right? It has two negative values. I put majority of the graph on this side. That has two negative values, two negative roots. And it has a negative y-axis intercept. So that's why I position the graph that way. I know that the majority of it is down here. Right? So I visualize it. So go like this. It's a sketch. Yeah. So what are the two negative roots? Have to be careful when we get two negative roots, guys. Have to be careful. Remember, negative values are larger in magnitude over here, so don't it? So for example, next one negative 1, yes, so can be negative 3, don't it? Good? All right. So 2 roots. One was negative 2, one was negative 3 over 2. Negative 3 over 2 is same as negative 1.5, don't it? So that must be the one right here, closer to the y-axis. Negative 3 over 2. And this one is negative 2. And this is 1.5. And this root is negative 6, don't it? Negative 6. Not the root. The y-axis intercept is negative 6. From the standard form, we got that negative 6. Y-axis intercept. See it here? Negative 6. Right? Then my turning point is this. Remember? Maximum turning point. Negative 7 over 4, 1 over 8. Negative 7 over 4, 1 over 8. Right here. Negative 7 over 4, 1 over 8. That's my maximum point. And then I want to answer this now. What is that? What part of the graph is this talking about? And put circle it in blue and mark it. What part of the graph is that talking about? Below the x-axis. It's talking about the part of the graph that is below the x-axis. Below x-axis. And it is this part of the graph that is below the x-axis. This part and this part. Those parts are obtained by x values that are to the right of this one and to the left of this one. See that? So my solution is outside the two roots, don't it? So f of x less than 0, my solution is x less than negative 2 union x greater than, need more space, write it smaller. X greater than negative 2, that's outside this root. Yeah. Write it that way. I put it like a bit tweet. Sorry. X less than negative 2 union x greater than negative 3 over 2. That's the solution set. You can do it like that. I can write x is such that in front of it. But the question says solution set. You see there? Solution set. So since it's a solution set, you really have to write it like this, like a solution set, like a set. X is such that, and you write this, these are as inequalities. X less than negative 2 union. This is a union. X greater than negative 2. So I'm going to give you a little rule of thumb now. You can remember. A little rule of thumb, like something that you can remember. Right? Over here. Add math students. Pure math students as well. When the inequality, so the graph is like this. If the inequality is referring to the two, let's call it the leg part of the graph, solution is outside the two roots. Outside. Outside the roots. Solution is going to be outside the roots. When the solution is, when the inequality is pointing to these two parts, let's call them the leg parts. Solution is outside the two roots. And if the two roots, and it's always less than the smaller root, x is less than the smaller root, greater than the larger root. Always. So the roots are R1 and R2. R1 and R2. R1 being the smaller one and R2 being the larger one. And it's outside the two roots. Then it's x less than the smaller root, union. And instead of union, you can say or x greater than the larger root. When the inequality is indicating the legs, the two leg part of the curve. If the inequality is pointing to the turn part of the curve, then it is between the two roots. So watch me now, let me do a little adjustment here. So whether it's a smile or a frown, it don't matter. Can I change this to a frown? Can I change it? How can I change them? Can't change it. Whether it's a smile or a frown, This is R1, this is R2. Once the inequality is talking about the two leg section of the graph, the solution is outside the two roots. Outside. And this is how you write outside the two roots. X is less than the smaller root, or X is greater than the larger root. It's like a standard. In this case, or out here, down here, so now, the inequality referring to the turn part of the graph. But there's a smile or a frown. If the inequality is referring to the turn part of the graph, turn part of the graph is always obtained by X values that are between the two roots. Between the two roots. The line between them. So down here is always between the roots. Your inequality, the solution is between the two roots. And when it's between the two roots, X is between them. Is greater than the smaller one, but less than the larger one. And if equal is on your inequality, then all you have to do is add the equal to this. And add the equal to this. If equal is on your inequality, it means that you also want the roots. Equal is on your inequality, it means that you also want the roots. You're putting the equal in your result as well. All right? That is it. Outside the two roots and you're between the two roots. So once inequality is talking about the turn part of the graph as here and here, the solution is between the two roots. Once inequality is referring to these two leg sections, those two parts of the graph, then the solution is outside the two roots. When I'm doing my quadratic inequality, I'm just looking to see whether it's between the two roots or outside the two roots I want. So when we do rational inequality, we're going to extend the knowledge of the quadratic inequality to complete the rational inequality. Because a rational inequality can be converted into a quadratic inequality. We're going to see that when the time comes. All right? So this is a solution for this one. But okay with that? But okay?
Yes, sir. Yes, sir.
All right, all right. Let's do another one, just like the other one. More maths equals better maths. So remember, next week, no. So the question is, do we go on to the next part of quadratics on Friday? Or do we come back to this? Tell you what, we're going to go to the next part of quadratics on Fridays, which is the sum and product of roots or the discriminant, one of the two of them. I don't see why I must come back to this. It's a one class topic. This is C-sec. This is C-sec for real. It is. This is C-sec. I could do another question then. Let us do another one. We'll just skip over 2021 a while ago, right? This is what 29. Let's see if 2018 asks us anything interesting. Let us see. Here's what I'm gonna do. I'm gonna give you guys a quadratics worksheet. That which would have been a classwork. And you do it and send it to me, and I send you the solutions for it. And based on the solution that I get, I decide if I do it again Friday. But I think it will be good for us to just move on and do the other part. Okay, this is just C-sec, really. I mean, I don't want to take any topic for granted, but this is really ridiculous. It's another one here. All right, let's do this one. Let's do this one. Let's do this one. They give us this function, and I want us to complete the square. Know that this is an x squared. negative x squared. You're going to factorize a negative 1. You're going to factorize a negative 1 in this case. All right? So g of x is going to be negative 1 into x squared. And if you factor negative 1 out of this, you're going to get minus x. And you get back the negative 3 out there. And compute the square inside here, I get negative 1 into x. The number in front, this is a 1. Half of 1 is a half. So you're going to put minus a half in the bracket. Squared. You subtract the square of this, which is 1 over 4. All of that in the bracket, minus back this 3. What did we do? The half of the coefficient here, so we subtract the square of this here, so every time, that's what you do. Can't go wrong. We're going to expand with the negative 1 now. Expand with the negative 1, we're going to get negative 1 times this, which is negative x minus half squared, minus give us a plus quarter, minus this 3 is same as 12 over 4. Change the 3 to 12 over 4. Or we get the 12 over 4, I will multiply it by 4 and divide it back by 4. I want to have the same denominator as 4 as this one. Then you consolidate the values. So you get minus bracket x minus half squared. This is minus 11 over 4. That is it. It's going to have a frown shape. This is the maximum value. And it's when x equals half. If this x equals half, that's when this becomes 0. All right? It says on the grid below, provide below sketch a graph showing the maximum point and the y-axis intercept. All right, let's put in the maximum point first. Let me see if this makes sense. The maximum point is half 11 over 4. 11 over 4 is how much? 3 is 2 and 3/4, don't it? 2 and 3/4, don't it? So it's half 2 and 3/4. See half here. So 2 here, so 3/4. Let's zoom it up. 2 and 3/4. 11 over 4 is the same as 2 and 3/4. All right. So let's mark out the 2 and 3/4. That's sketch still. But this is a half for the x coordinate, half. And then this is 2. Right here is 2 and a half. So this is right here about 2 and 3/4 there, so don't it? I'm gonna put the maximum point here. 2 and 3/4. Good? Then the y-axis intercept is negative 3. Negative 3. The y-axis intercept is negative 3. That's a graph look funny though. There's a frown. And so this is not right. It's a negative. Not right. It's a negative. Negative level of negative. Wrong place we have it. Negative. It's down here, say there. Something was wrong. Negative we have. Negative 2.5, negative 2 and 3/4. About here. All right. And it frowns. It actually pass through this, you know. Negative 3. Pass through this. And it's gonna pass through here as well. The graph is symmetrical about this, right? The same distance will pass through 3 here, so same distance can pass back through 3 there, so that's symmetrical graph. So this is actually the maximum point right here. Minus 11 over 4. And then we want us to sketch it. Because I put it on a grid, I work out a couple more values. But I put it on a grid. So for example, I work out maybe for 2, which is when x equals 2. Let's look at it. Function is this. I'll put 2 in it. So that's all right. X equals 2. So I'm working on g of 2 is minus 2 squared plus 2 minus 3. What is your equal to? This is -4 and -2, -6. No, not 3, that's 3, not 2, 3. Don't give it away, Mr. Shaw. -4 plus 2 make -2. -2 and 3 is -5. So when x is 2, we're at -5. -5, we're right here. Now look here, the graph is symmetrical enough. I don't have to draw on the moon. Watch this now. This is my line of symmetry. Put it in red. This is my line of symmetry, right? So 1, 2, 3 units to the right. Take me down to 5. 1, 2, 3 to the left is also going to take me down to 5. So we can bet you any money that -1 going to give a -5. So this is a point on the graph. Right here. Right here. Want to try it? Let's make sure. When x equals -1, you get -1 squared. And then you're getting -1. So this is a plus x, you know. This plus x means -1. And then -3. This becomes -1, which is still -1. -1 squared is -1. -1 minus 3. That's -5. Correct. -1 is -5. So we're going to pass through those points as well. So I will draw it like this. I just do like that and done it. That's my sketch. Good enough. A quadratic graph, so it is symmetrical. Then show the y-axis intercept, which is here, and the maximum point, which is there. And I put on 2 additional points to sketch it. That's it. That's it. So what after the range of this function? We don't give it a done in. X is real. What's the range? What's the range of this function? Range. What is the range? This is the domain. This is the domain. G of x is less than or equal to this maximum value. -11/4. -11/4 is the maximum value. So G of x is less than or equal to that maximum value. People online, okay?
Yes,
People
sir.
online, okay? All right, let's look at another one. Let's look at 2017. Let's look at 2017. So Friday we're gonna do some real quadratics, right? Some unproduct of roots, right? Or oh, by the way, some unproduct of roots in ADMATS and the quadratic is preparing us for the sum and product of roots in pure math and the cubic. So the same thing that they'll ask you for the sum and product of roots in quadratics, they'll ask you the same thing for the sum and product of roots in the cubic function in pure maths. Very frequently said question. Sum and product of roots in pure maths. They're the same concept we're using to do it. Just that in pure maths, you're getting 3 roots. In ADMATS are quadratic, so it's only 2 roots. So the concept and the approach is the exact same thing. All right, there's nothing to it really. Nothing to it. Like this, we're going to do this Friday. Alpha and beta. Sum and product of roots. Add much that. Oh, there are no quadratics on this paper. There are no quadratics on this one. Let's look at 2016. So want us to determine the roots of this. And then sketch a graph. And show the minimum. Right? So this one I want us to determine the roots. To solve that. One market, oh, the nature. You know, I find the roots. They want us to sketch a graph and show the minimum value. All right? All right, let's do this one. Let's do that one. So to get the minimum, I'm going to complete the square. See where the minimum is, right? This asks us for the nature of the roots. We're not going to do that yet. That is b squared minus 4ac equals 3 squared minus 4 times 2 times negative 9. That is greater than 0, you know. I'm going to say greater than 0. Because negative times negative is positive. I don't need to know the value. I just need to know it's greater than 0 or not. It's greater than 0. So since it's greater than 0, roots are real and different. Real and distinct roots. The two different roots. That's what it has, right? One complete the square of this. More practice. Let's go. So let's do it over here. So I'm going to say f of x equals, I'm going to factorize the 2 out of these two terms. 2 into x squared plus 3 over 2 2x minus 9 equals 2 into x plus half of this is 3 over 4. Don't forget the square. Minus the square of this is 9 over 16. And you're subtracting 9. Good? Then it becomes expand now. We get 2 into x plus 3 over 4. Pen giving me hell. Need a new pen. Squared. Then 2 times this is 9 over 8. Minus 9 over 8. And this is same as 9 times 8 is 72. So it's minus 72 over 8. I'm going to get that. Multiply the 9 by 8. And divide it back by 8. And then this works out too much. 81, right? So we get 2 into x plus 3 over 4 squared minus 81 over 8. So it's a minimum point, right? I want the minimum value. So that's right, the minimum point. X value is when this equals 0. That equals 0, the next equals negative 3 over 4, right? The next value there is negative 3 over 4. And the minimum value is this, negative 81 over 8. Negative 81 over 8, which is really 10 and 1/8, right? 10 and 1/8. Graph is going to have a smile shape. All right, so if we're sketching it, and all I want us to show is the minimum value. That's all I said must show. They don't ask us to show the roots. All right, they didn't ask us for the roots. We're going to have a y-axis intercept of negative 9. So let's sketch it. More to the right. Yeah. The formula. All right, hold on. That's how it is. Negative x value and negative y value is down here, so in that quadrant, right? And the y-axis intercept is negative 9. That's why I make it cut the y-axis down here. So if I were to label it, right here is negative 9 on the y-axis. Right here, negative 3 over 4, negative 81 over 8. And that's it. That's a sketch. Just need to label it up, right? Label it up, sketch of f of x, put on your y-axis and your x-axis. All right, so the formula to find xt, this one. Xt formula is minus b over 2a to get this value. And the yt formula, this value, is 4ac minus b squared divided by 4a. But I don't think I want you to use this method at this level. I don't think I want to use the formula method. I think I want to use the process method today. That's how we can get those values. Right? Xt and yt. Right? Those are coordinates right here. Them formula I can give it to you. And the a and the b come from a standard form, you know. Here. The a is 2, the b is 3, the c is -9. All right? But I don't think I want that process. I want the process method. And what have you at this level. All right. All right. So let me put up on the screen. What time is it now? I'll put up on the screen what I want you guys to do for the week. All right. C6 stuff. C6 stuff. Screenshot it for me. I want you to do this 5 questions. There's some other stuff in here that we didn't do today, but it's still C6. Just tell it quickly. Just tell it quickly. I'm going to tell it quickly. Sorry. Don't screenshot it. I'm going to tell it quickly. So these two are normal quadratics. Complete the square, maximum, minimum. I have to make a sketch. This question is asking also for range, I think. Where is it? See? Find the range for the given domain. All right? Find the range for the given domain. X, Y, Z graph, cut the x-axis are your roots. You're going to calculate those. And you have to sketch it, right? Sketch it. The other one is a frown shape one. See that? And this is the domain. -1 to 2 is the domain, right? Based on that domain, you're going to also have to find the range. Find the range for that domain. All right? I want to do it, you know, find the range. And you have to sketch it again. Sketch it. And sketching it for this domain, guys. You're sketching the entire graph. You're sketching it for the domain. All right? This question is just a simultaneous equation of a line and a curve. You're going to end up getting a quadratic in it. That's why I put it here. We do simultaneous equation of a line and a circle in the other day. So, simple thing. Line and a curve. This one is a quadratic inequality. Remember, put the quadratic in the standard form. See what the sketch is going to be. You're going to need the two roots because your solution is either between the two roots or outside the two roots. Get me? So like this one, expand it out, transpose it over into the standard form with the sketch. If it's greater than 0, you know, say the two-leg part you want. Solution is outside the two. If it's a smile graph, because the A positive, and it's greater than 0, you know, say the two-leg part you want at the top. Solution is outside the two. So you have to find the two roots. When you find the roots, the quadratic equals 0 and find the root. Or if you go back to your factor remainder theorem, if you factorize them and you know the two factors, then you automatically know the two roots as well from the factors, right? You can apply a factor theorem knowledge as well. Or you can solve for the two roots. That's that one. This one again, another one right here. Same thing. Transpose it over into the standard form of a quadratic inequality. See what the sketch is going to be like, whether that's a smile or a frown. You have to find the two roots again. And then based on the inequality, whether above the x-axis or below the x-axis you want, the solution is either outside the two roots or between the two roots. But this one down here now, these two. These are just these guys' quadratic equations, you know. That's all they are. this guy's quadratic equations. So you can call the thing y, for example. Like for this one, you can make y equal x cubed. So this would have become y squared equals 6 minus y. Get me? Which are quadratic. After you find the y value, you put it back equal x squared and solve. This one, if I multiply 2 by root x, I'm going to get 4 root x. I'm going to 4 root x squared minus 8 root x plus 3 equals 0. That's a quadratic. One variable is root x, so I can write it as 4y squared minus 8y plus 3 equals 0. It's still at this guy's quadratic equation. You just make y equal root x. After you find the y, you put by the y equal root x and you solve. You get me? So there's nothing to it really. So I want you guys to work these questions for me and send them. When you're done, I'm going to send the solutions for them. We're not coming back to this on Friday. We bought back these when we're doing questions, past paper questions. We're not coming back to this quadratics, compete in the square business. Quadratics that we're coming back to on Friday, guys, let us move forward. Is either sum and product of roots or might the discriminant. Now listen to me now. The whole business of discriminant is far more than just saying the roots are real and different, or the roots are real and equal and so on. Far more. The application for it is very deep. The questions can be diabolical if you don't understand certain basic things. The issue is that at AdMaths now, you will only be getting the very basic things. Right? You'll only be getting the very basic thing, but because me want to really learn this thing, I'm going to teach you this thing at a higher level. The sum and product of root based business and the discriminant. The discriminant B square minus 4AC, very powerful. Just at that AdMaths, I must ask, so determine the nature of the root, determine the nature of the root. Salama ask. You're not really setting in the question where you apply. The pure math students know the application of discriminant of the roots can be rooted in some questions that you do in pure maths. So you have to understand it at a level higher than just knowing that the roots are real and different, that the roots are real and equal and so on. You understand me? They can shorten knowing how to apply the discriminant of the roots can cut off 6 lines off of one question where you try to. If you don't know it, you need 6 lines to complete one question. But if you know that, you cut off 6 lines by applying the discriminant of the roots. Pure maths. They're not asking AdMaths students to do that. Not now. They're asking AdMaths students the very basics. So because I know that, we are going to do discriminant of the roots to a higher level, gentlemen. Telling you from now. I think that is what I'm going to do Friday first. Discriminant of the roots. Next week, we'll do sum and product of the roots. Same thing with sum and product of the roots. Same thing again. Let me tell you what sum and product of the roots again. For AdMaths, they will ask you only the most basic thing with the alpha and beta thing. But they can go much deeper than just the most basic things. And because pure math students are here, you have to do that again at a higher level than they would require in AdMaths. I showed the AdMaths question and showed them for the basic. For the pure math students, they have to learn to do more with it. Because they have to extend the sum and product of root of a quadratic equation. They are going to have to do sum and product of root of a cubic equation. And they have to be able to do more with it than required in AdMaths. You get me? So the same thing that the pure math students will be required to do with the 3 roots in pure maths, we are going to do it with the 2 roots in AdMaths, even though it's higher than what they'll ask you in the exam in AdMaths. What will be for sure is that the AdMaths question will be very easy for you. Good? That's gonna be our approach. So I'll decide which one of them we're doing on Friday. The come under the quadratics topic. All right, so moving on, gentlemen. So, and lady, work out these questions for me, please. They're very easy. And send them to me. And I'll send you the solutions for it. All right? All right, that's it. Everybody online heard me? Everybody good? Ladies
Yes.
online, you heard
Yes,
me?
sir. Yes, sir.
All right, good. All right. So write these questions for me, screenshot it, write the questions for me, send me the solutions. I will send you the solutions. We're moving on to another topic, another part of quadratics on Friday. All right, that's the plan. Moving on Friday. We're preparing more for what is coming on pure maths. That's what we're doing. We're preparing ourselves for what will come on pure maths. All right, bye everybody.
Bye, sir. Good night.
All right, good night.
Bye, Dad.
Bye-bye. Bye, Kai. Bye,
Bye.
Avia.